Hey folks, I'm Trent, and in today's video, I want to take you through a methodology in software engineering that I think will enable you to write the best code you've ever written, and that is the methodology of test-driven development. Before I jump into that methodology, first we need to understand, well, what is a test? Now, generally speaking, when a developer refers to testing, they're actually speaking to a specific type, or speaking about a specific type of testing called unit testing, effectively testing isolated pieces of your code to check that they work as expected. And really, you can think of a test as an experiment. In the experiment, you are checking that given some input, your code behaves in an expected way. So to illustrate this point, I'm going to be using Python, but this is generally applicable to any programming language. Every programming language I've used has the notion of tests. So let's jump into an example. Let's say you're writing a function that divides by 2. Effectively, given an input number, you want to divide that number by 2 and return the output. Now, purposefully, I'm dividing by 3. So that's an on-purpose mistake. That's just to illustrate what happens when we test this. Right. So without using anything too fancy, just using base Python, I could write tests. So this function over here, test divide by 2, effectively what I'm doing is writing an assertion. So I'm saying assert that the result of divide by 2, when I give it 4, is the number 2. If I do that for 10, it should be 5. If I do that for 100, that should be 50. All assert does is evaluate the left-hand side and right-hand side of this double equal sign to check if they are equivalent. Right, so if I go ahead and run this code, let's go Python, simple example, run that, I'm going to get an assertion error. As I said, I've written this to divide by 3 on purpose to show you that the assertion fails because if I enter 4 and expect the value to be 2, but I'm dividing by 3, the assertion is going to fail. If I change this back to 2 or 2 and run this again, I get the output over here. It says all tests passed. Now, this is great for testing my code, but there are frameworks in Python that make this process a lot easier and a lot more informative and way more convenient to do. One of the more popular frameworks to do this is Pytest. Now, in base Python, there's already a framework called unit test. I don't use it that much. Personally, I use Pytest, so I'm going to take you through using Pytest. Now, in order to use Pytest, you're going to need to install it. So to do that, let's say pip install Pytest. Now, I've already done this earlier, so all of my requirements are already satisfied. If you don't have Pytest installed, it would obviously go and download that for you. Great. Now, the great part about Pytest is that it recognizes functions with the keyword test underscore in it and recognizes that you are doing testing. What do I mean by that? I think we can just illustrate that by running Pytest and saying simple example.py. Great, so our output over here says that we have one passing test in 0.02 seconds, and it has shown me the script that I'm running over here, simple example, and one green dot to indicate that I have one test, and it's passing. Just to show you what the output would look like for a failing test, let's run it with a divide by 3. Great, so this has shown us that our test is now failing, and it gives us some useful feedback to say assert 1.3333 recurring does not equal 2 over here, and that's the problem. This is a bit more informative than what we had before. Instead of just failing the assertion, it also tells us why the assertion failed. If we switch that back to 2, we should get a passing test. Great. So that's how to use a framework like Pytest to make the process of testing your code easier. And also, I hopefully have illustrated to you what a test is in the context of software engineering. Now, what is test-driven development? Now, this is a methodology that leverages this idea of testing, but its core principle is that you should write tests before you write any logic for your code. The pattern that test-driven development follows is sometimes called red-green refactor. Basically, this means you should write tests and they should fail red, like we kind of saw the output of Pytest was red when it failed. And why your test should fail first is so that you validate you're not just writing dummy tests or tests that just pass by default. That's useless to us, right? It gives us no feedback or context as to why our tests, why our code is not working in an expected way. It's just a passing test. That's the red part. The green part is then you would go and write code that passes the tests you've just written. And that would give you the green output, right? Like we had in Pytest. Then finally, the refactor step is looking at the code you've written to pass your test and evaluating, is this the most efficient solution to the problem? Could I refactor it? And if the answer is yes, I should probably refactor this. I can make my code look better or be more efficient. You go ahead and refactor it, rerun your test, and ensure that you're still in the green state, or that all your tests are passing. So to illustrate test-driven development, let's look at a more complex example. Exit out of this, clear my terminal. Let's say that you are writing a program that converts currencies given a set of currency conversion rates. So for example, in this JSON file, I have US dollars, euro, and Japanese yen, and as their values, it's their conversion rates to the currency. So for example, USD to euro, this rate tells us that it's 0.92 for euro and 134 Japanese yen, etc. So given these rates, I want to enable a user to input a source amount, source currency, and a target currency, and the result that I get back out should be the converted amount. Now, to illustrate the benefits of test-driven development, as a challenge, if you want to go ahead and pause this video and try and solve this problem in Python or your preferred programming language, just check how would you actually write a function like this. Great. If you've given that a shot, awesome. If you haven't, that's cool too. Let's jump into it. So if we were to approach this problem with no tests in mind, your code might look something like this. In my file over here, a currency converter without TDD or without test-driven development. Basically, we have a main function over here that's being called. I'm just using the JSON library over here, or JSON module, to handle the JSON file containing our currency conversion rates. Basically, to explain this bit of code, we would go ahead and collect an amount from the user, input an amount, input a source currency, input a target currency, then go and read our rates from the JSON file, then get a result, amount times rates, get the source currency in our JSON file, or in this case, when we read it in, it would be a dictionary, get the source and the target currency to get the rate to, or the rate to multiply our amount by, and then print out the result. So to illustrate how this works to you, let's go ahead and run it. Python currency converter without TDD to start off with. Let's enter in 100. Source currency, let's say we've got $100, and our target currency is maybe yen. Great. So we now see the output. 100 USD is actually 13,000 Japanese yen. Now this works as expected under the usual conditions. Great. We could stop there and leave our program as is. But really, if we look at this, you may already be saying to yourself, well, this isn't split up nicely into functions. And we're not handling edge cases as well. What happens if a user enters in a currency that is not actually in our rates file? So if I enter in 100 and then make up a currency like foo, and the target currency is maybe bar, well, my application just errors out and gives me this key error thing, which is not very readable for a user. You know, we may want it to raise an error in this case, but we'd probably like something that that gives us a bit more detail. Great. So with this example in mind, how would we approach this using the test-driven development methodology? So to start things off, if I go ahead to my file that I've got set up here, currency converter with test-driven development, The first thing I would do is actually just write what I call, or what is called, function signatures. Basically a set of functions without any logic in them, and maybe their inputs as well, that I want to say decompose our problem into units or isolated pieces. So already what I've thought about is, well, looking at this previous code, this isn't very testable, or it's hard to test. Sure, I could write a bunch of scenarios and see that the scenarios work out, but I want to test each and every step of my code, or each and every step of my application. So the first logical thing to do is actually split this code out into functions that are testable in units, right? And that's before we've even written tests or anything. The first benefit of test-driven development is it makes you think about your code being more testable. And your code being more testable means it's more modular. Basically, you're writing isolated pieces of code that you can mix and match together. And that's more adaptable to change. Anyway, I digress. So I am writing my function signatures first, which is a bit of a cheat, right? According to the strict definition of test-driven development, I should write my tests first. But generally, this is the workflow that most developers follow, or this is the workflow that I follow. I would write my function or class signatures first, so basically some skeleton code, and then go ahead and write some tests. So to jump into the test writing, generally I like to put my tests in their own file, even in their own subdirectory, where I keep them all together. But in this case, to keep things simple, I'm actually going to keep my tests in a file over here. So in this file, test currency converter.py, the first thing I'm going to import is Pytest. I get a whole bunch of cool outputs, or sorry, cool modules and functions that I can use from Pytest that are convenient for testing. So generally, I just import Pytest. And the next thing I need to import is the actual function that I'm testing. So for the purposes of this video, and to keep it pretty short, we're going to import convert currency. Let's write tests for this function. Now I've gone ahead and written 3 tests, and to come up with the different tests, the pattern I like to follow is to first think about the status quo, or just the kind of usual operating conditions. It's my first test. So this first test over here is test convert currency converts between 2 currencies, that kind of usual vanilla operating of your function. Then what I like to do is think about what happens in edge cases. For example, if I test convert currency, I expect it to raise a value error if the rate is not found. Now, a value error, in my opinion, is descriptive enough to a user to express what the problem is. You may have a differing opinion, and that is a design choice. You can determine what you want to do in the scenario if the rate does not exist in the rates file, or you can't get that currency rate. But this is part of test-driven development, is you're thinking about your function's design. And lastly, as another edge case to test, we're going to say test convert currency returns amount if source and target currency are the same. Basically, if I'm converting US dollars to US dollars, I'm returning the same amount, or should return the same amount, right? That's another edge case to handle. So I like to write out these test names to think about, well, what am I going to test for? What are the edge cases I want to deal with? And I do this until I'm comfortable that I've touched on all the different cases for my function. All right, let's take a look at the vanilla test that I wrote over here. So this first one, what I'm doing is setting up what I'm calling mock rates. Now, mocking is a topic in and of itself, and that can go quite deep. Maybe we can handle that in another video. But what you need to know for now is mocking enables me, or creating a mock rates object enables me to control what rates I pass to my function. So I'm controlling the inputs to see how function will react. So I've just literally copied and pasted my rates file into this dictionary. And what I'm going to do is assert that convert currency given 100 US dollars, convert to euro, and given these mock rates should give me a result of 92.0. And how I got to that is if I look at USD to euro, the conversion rate is 0.92. So under these conditions, I expect convert currency to produce a result of 92. Great. Now let's take a look at one of my edge cases. Raises a value error if rate not found. So in my mock rates, I've removed euros completely. And what I'm checking is that my function should raise a value error. Now this is one of the, I want to say, modules that Pytest gives me that enables me to test that my function returns or raises an error. So the expression is with pytest.raises value error convert currency, and I give it the input of euro, or one of the inputs as euro. It should raise a value error according to my design over here. And similarly, or not similarly, but in the case of if the source and target currency are the same, I want to check that when I convert a currency, let's say 100 USD to USD, given the mark rates, I should get a value of back. So I've written my tests. That's step one of test-driven development done. But I have not opened up the correct file here. I have not written any code. Let's actually open these up side by side. I've not written any code under convert currency. So let's see the result we get and start off the process of getting our red results or failing results. I expect all three of these tests to fail. Pytest, and we want to run test currency converter.py. Great, so we get our three failures. So we're in the red state in test-driven development, and we can see that the failures are how we expect the code to fail. So an assertion error, none does not equal 92. Currently, this is returning the none type. Our test convert currency raises a value error if rate not found. It did not raise a value error. And finally, test currency converter that it returns the same amount if source and target are the same. We are asserting that none equals 100, which is not true either. All right, so we're in the red state. Let's try and move into the green state by writing some code that will pass our tests. Let's go and write the code for convert currency. So the first thing I'm going to do is say result equals, let's go ahead with amount times rate. And maybe to make this a bit clearer, I'll close that for now. Rates, and we actually want, source currency, that's true, but we want to select target currency like that, and then return result. Yeah. Great, let's run our tests again. Awesome, so we got one pass and two fails. The two that are still failing is raising a value error if the rate's not found, and converting the currency if the source and target are the same. Those are still failing. Okay, so let's try and deal with those cases. So to raise a value error, what I want to do is say try over here. Try do this and then set, and we set a key error or expect a key error. The key error comes through. We actually want to translate that into a more useful error of value error. This is invalid currency pair. That's the suggestion I got from Amazon Q that I'm using, but I actually don't like this message. I wanted to say something like, given currency is not in rates, like that. And then if all this goes okay, then we return the results. So let's run our tests again. Okay, we've got two passes, so now we are raising a value error under the correct scenario. Lastly, we need to deal with the source and target being the same. So what I'm going to say, actually, need to think about this one, right? Because we want to, simply return the amount if currency is the same. So let's go ahead and write it this way. So we can say if source currency is the same as target currency, return the amount. Straight up like that. Let's go ahead and run that. And yay, we get 3 passes. Cool, we're in the green state. Awesome. Now we enter the last phase of test-driven development and say to ourselves, is this code as optimal as it could be? Does it look as nice as it could be? Well, the first thing that I'm thinking about is this check over here, if source currency equals target currency, doesn't actually look if the currency is in our rates file. Do we actually want that behavior though? Like if someone just gives me 2 random currencies, or not even currencies that exist, do I actually want this to simply return the amount, or should it error out? In this case, we would go ahead and refactor our code for that case. And then ensure that our tests pass, or extend the number of tests we have. We could write some more tests to say, well, if the currency doesn't exist, I just wanted to throw an error in any case. But you get the idea. Now, I've shown you how to do this for a single function. We would go ahead and repeat for all the other functions. And I'll leave that as an exercise to the viewer if you want to take a look at that. But just with this simple example, just one of these functions, you can see that we're already thinking more deeply about our code and what it should do under different circumstances. Great, so just to address couple of concerns around test-driven development, or a couple of, I want to say, common qualms I hear about TDD. The first is if I have an LLM like ChatGPT or Amazon Code Whisperer or Amazon Q, why should I bother with writing tests? These LLMs are writing code for me, and they write pretty good code in the first place. Why should I go ahead and test it? Well, in my experience, the workflow that I like to adopt is I actually get the LLM to first write tests for me. I express what I'm looking for in my function and get it to write some tests in Pytest for me. Then I look through the tests, evaluate that it's testing for the right scenarios. In most cases, I've actually gotten some good ideas about scenarios by asking the LLM to tell me about different scenarios of what could go wrong for my function. And then if I'm happy with that, I can then ask it to write the code that passes those tests. And I found that I get way better results by following that kind of workflow. The other, so that's how I would justify still doing test-driven development in this age of LLMs. The other qualm I get is that, well, test-driven development makes me really slow, right? It's much harder and much slower process to actually write code when you're following test-driven development. Now, the thing is, or my argument against that, is that it's slower in the short term, but in the long term, the gains are exponential. You're actually faster in the long term. And what do I mean by that? Basically, if your code is going to have a long lifespan, its requirements are going to change. In the case of our currency converter, maybe the requirements change such that you actually need to go and fetch the currency rates, not from a file, but from an API, meaning you're going to have to go and refactor your code. And by having tests available and doing testing, your code is more modular. And also, you can see how you're affecting the code when you're changing it. So that modularity really gives you the benefit of being able to refactor and change the code's functionality way faster than if you had just written a bulky kind of monolithic type of script. And you can also see what your changes have done to affect all the other pieces of the code, or does it actually affect the other pieces of the code? So those are my kind of responses to those common qualms. Anyway, I hope you have enjoyed this video. And if you did, please like it, share it, and I will see you in the next one. Thanks so much.